Looking at section 3.5, part 2, picking up with example 3. We're going to look at solving a system using substitution. So the last two examples that we did, we used a bunch of elimination. If elimination works, you're more than welcome to use it, but there are some cases where substitution is just going to make more sense. So if we look at the system that we have an x minus 2y plus z is equal to 1. We have a 2x plus z is equal to 9. And we have a negative 3x plus y is equal to negative 3. Now notice the first equation has x, y, and z. But the last two equations, they only have two variables. So if we look at that middle equation, 2x plus z is equal to 9. Well, z is almost by itself. It almost makes sense to take that middle equation here and solve to get z by itself. And then you can use substitution. You could take out the z variable and just plug in whatever's left over. And that would eliminate one of those variables because the only ones that have the z variable are the first and the second equations. So if we take that second equation and get z all by itself, we'd have to move that 2x, and we can do that by subtracting 2x to the other side equal sign. That means we would have a 9 minus 2x if I just rewrote that equation. Now, I could take and I can replace the z variable in that first equation with that 9 minus 2x, and then all I have is x and y, and my third equation is only x and y. But if I look at my third equation, a negative 3x plus y is equal to negative 3. I can do multiple substitutions at one time. I can solve to get y by itself very easily in that equation by moving that negative 3x over. Well, if I move a negative 3x over, that means I would add 3x. That means I would have had that negative 3 that would add 3x. Everybody seeing what I'm doing? So that middle one, I would have gotten rid of that 2x by subtracting 2x to the other side. That's where that 9 minus 2x comes from. And in that third equation, I moved that negative 3x over by adding the 3x. That's where that negative 3 plus 3x comes from. And now I have two equations that only have x in them. So just like we would have done with that z was equal to, we could also go up here and replace the y. So let's see. If I take this first equation here, we have an x minus 2y plus z is equal to 1. And what I'm going to do is I'm going to replace my y variable with this expression for y. So that means we're going to have, in place of that y, let's see, we'll have an x minus 2, and if I take out y and I replace it with a negative 3 plus 3x, and then I have plus in place of z, we said z is going to be a 9 minus 2x. So I have a 9 minus 2x, and that all is equal to 1. So you see what we did? We're going to substitute an expression for the y value. We're going to substitute an expression for the z value. And then we can go ahead and just solve this out and see what we got. So let's see. We have a little bit of distributive property going on here. That's a minus 2 that has to multiply in. So we have this x. We're going to end up with a positive 6. We're going to end up with a minus 6x. Now, all I have is a plus, and there's nothing that needs to be distributed, so it's just a plus 9 and a minus 2x. Let's get all of our x's together. Let's get all of our plain numbers together. So we have an x and a minus 6x and a minus 2x. So x, take away 6x is negative 5x. Negative 5x with a minus 2x, that's going to give us a negative 7x. I have, let's see, we have a plus 6 and a plus 9, which means that we have a plus 15. And all that is going to equal 1. So let's solve to get x by itself. So, oh, look at that. What does it ask us to do? What is the x value? All I got to do is find out what x is, and I'm done. So let's solve and figure out what x is. If I want to get x by itself, I'm going to get rid of that plus 15 by subtracting 15. So negative 7x is going to equal negative 14. Divide by the negative 7, and x is going to equal positive 2. And all they wanted was what is the x value of the solution of the system. Now, if it asked for the whole solution, you would just take that 2 and go back and plug it in for x here and for x there, and you'd get your y and your z values, but they didn't ask us for that. They just want to know what the x value is. All right, so example 4, solving a real-world problem. You are an office supply distributor and budget $7,200 for 80 office chairs. You can buy leather chairs for $125 each, mesh chairs for $100 each, and fabric chairs for $75 each. If you want to have 3 times as many fabric chairs as leather chairs, how many of each type should you buy? Excuse me. All right, we have 3 types of chairs, which means we need 3 variables, and anytime you have a word problem, always define your variables first. I like to stick with X, Y, and Z. So, excuse me. First type of chair they tell us that we have is leather, so I'm going to use X for leather. The next type of chair we have is mesh, so I'm going to use Y for mesh. And we have fabric chairs, so we're going to use Z for the fabric. Now let's go back and see what we have. You're an office supply distributor and budget $7,200 for 80 chairs. So we have money and number of chairs. You can buy leather chairs for $125 each. So 125x. Mesh chairs for $100 each. 100y. And $75 for our fabric, so 75z. So money plus money plus money is going to equal $7,200. Money plus money plus money equals money. Now, how do we make up the 80 chairs? Well, that's going to be x plus y plus z. Chairs plus chairs plus chairs is equal to number of chairs. Let's see what else they tell us. It says if you want to have 3 times as many fabric chairs as leather chairs, how many of each type should you buy? So our third equation we have to think about a little. It says if you want to have 3 times as many fabric chairs as leather, which one do you have more of? Well, you have more fabric chairs. So fabric, which is Z, is going to equal 3 times as many leather. So leather was X, so Z is going to equal 3 times X. The number of fabric chairs is 3 times the leather chairs. All right, so let's see what we got. We can substitute. We can eliminate. Let's see what we got. That last equation, Z is equal to 3x, tells me I want to do some substitution. I want to take wherever I see Z and replace it with a 3x. And wherever I see a Z, replace it with a 3x. And then let's rewrite out some of these equations here. So if I have a 75 times 3x, 75 and 75 and 75, that's 225x. And I have 125x. So let's see, 200, 350. So we'd have a 350x plus that 100y is equal to our 7,200. And if I simplify that second equation, we said we had a 3x plus a 1x, which gives us 4x plus y is going to equal 80. So I just simplified my 3 equations and 3 variables down to 2 equations and 2 variables, and that's back to an Algebra 1 problem. Do you want to eliminate? Do you want to substitute? I think I might eliminate because I can multiply that second equation by a 100 to eliminate the y variable, but I'm going to make that a negative 100, so my signs are what I'd like them to be. So let's see, if we rewrite out these equations, we have that 350x plus 100y was equal to 7,200. And if I multiply through by that negative 100, we're going to have a negative 400x. We're going to have a minus 100y. And we're going to have a negative, let's see, 8 with 1, 2, 3 zeros, so negative 8,000. And we are ready to do some elimination. Our y variables are going to cancel by adding them together. So positive 350 with a negative 400, that's a negative 50x. 7,200 with a negative 8,000 is going to give us what? Negative 800. Divide by negative 50. So x is going to equal, let's see, we'd end up with 16. Hey, it's a whole number. That's kind of important because we're talking about number of chairs. If I got a decimal, that means I did something wrong because I can't buy part of a chair. Not at this manufacturing or distribution center, right? X equals 16. I have one answer. I'm going to go back up here, and that means that we're going to end up with X value. We have 16 leather chairs. Let's see. If X is equal to 16, we know that Z was equal to 3 times X, so we'd have 3 times 16, which is going to give us 48. That means that our fabric chairs is going to be 48. And if we add all X, Y, and Z together, we get 80. So let's see. I'd have a 16 plus Y plus 48 has to equal 80. 48 and 16. So 48, 58, 60, what, 4? 64 plus Y is equal to 80, which means that Y is equal to 64 to 80 gives us 16. So that means we're going to end up with 16. So that means we have 16 leather, 16 mesh, and 48 fabric. And if I take all three of those numbers and plug it into even that first equation with all the money, it would end up working out 125 times 16, 100 times 16, and 75 times 48. It would end up being the $7,200.